Hey guys, Mr. Covey here. Sorry I'm not at school today. I'm homesick with my son and daughter. So sorry I'm not at school today. I won't be here tomorrow either. But then I'll be back in the block day. Don't worry. I just wanted to kind of outline what were the plans for today. So first, I want you to watch this video, which you're doing right now. Check. So that's good. What I'm going to do in this video is explain the plans for today and also go over some harder algebra related to function notation. Okay, so we're going to kind of pick up where we left off on Friday, but I want to see that some of the problems have those quadratic and exponential functions, and so the algebra we're going to have to do is a little trickier. The second thing I want you to do is to watch a video Mrs. Fry made called Function Combinations. It's about a 15-minute video. It goes along with your note packet. I don't think it's that tricky of a topic. It's basically like, hey, you have two functions, you can add, subtract, multiply, or divide them. I don't think it's that bad. So the second thing I want you to do is watch that. And then the third thing I want you to do is you can start your problem set. Start working on your problem set. Cool. Reminder, your locker is due tomorrow. That locker assignment, that virtual locker, that is due tomorrow. Cool. On the block day, we'll do a get to know you thing with it. It'll be fun. Cool. All right. So in this video, I want to go back to our note packet and jump back in with some of these problems here. So depending on which class you're in, I want to start with number 2 here. So we said the blue function was exponential and the green or the red were quadratics. And so number 2 is saying find the input with an output of 18. Okay, so this is not a plug-in, this is a set equal to. And we're going to solve this equation. I think we solved this in your class, but I just want to recap real quick. This is quadratic. We can't use square roots because we have an x squared and an x term. Instead, we have to move it all over to one side. And we have to use factoring. What multiplies to negative 18 and adds to 3, you should get 6 and negative 3. Those are the numbers that multiply to negative 18 and add to 3. And then don't forget those are the factors. And then so to actually get your solutions, you got to flip-flop those. And so you get x equals negative 6 and x equals 3 as your solutions. I will expect you to remember how to factor. That's why we're reviewing this algebra now. I need you to know that. Cool. I want to do 3 and 4 with you guys too. So 3, again, is a solve one. We're trying to find the input. It gives us the output. We're trying to solve this equation. Okay. This is an exponential equation. We'll have a unit second semester where we review how to solve exponential equations. But for now, I just want to bring it up and see what we can do with this. I think your intuition would tell you subtract 7 from both sides to start. At this point, there's a few different ways to solve this. There's a fancy way, which you probably, maybe you remember, but you probably don't remember, which is cool. That's why we have a unit on it. The fancy way is to use logarithms. Okay? I don't expect you to remember how to use logarithms. If you do, that's awesome. If not, you can figure out the answer to the solution just by using your times tables, thinking about how it works, using your brain. 2 to what power equals 32? It's a nice number. Well, it's not 2 squared. That's 8. 2 to the third, or sorry, that's 4. 2 to the third is 8. 2 to the fourth is 16. No, it's 2 to the fifth. Yeah? So you can kind of just use guess and check, some number reasoning to figure out the solution to that equation. I don't want you to worry about the actual algebra. We'll review that second semester. Cool. Let's do number 4. Similar to number 2. Quadratic, I can't use square roots. I'm going to move it all over to the same side. Now the factoring we have to use here is different. Why? Because we have a leading coefficient that's not just 1. So instead of having an x squared, we have a 2x squared. Okay? I'm going to show you 2 different ways to do this. I will expect you to know this. This might be something that you need to review. I will show you first something called split the middle, which some of you probably use, a lot of you guys probably use, and that's this idea. It is literally we're going to split the middle term, that 3x, up into 2 different things, okay? You're going to split it into 2 things that add to 3, so like 5x and negative 2x, or 9x and negative 6x, but you have to figure out how to split it. And the way you figure out how to split it is you do 2 times negative 9, so you do 2 times negative 9, and you get negative 18. And you think of 2 numbers that multiply to negative 18 and add to 3. Multiplies to negative 18, adds to 3. 6 and negative 3. And that's how you split the middle. That tells you how to split up that 3x. So we're going to split it into a 6x and a minus 3x rather than a 5x and a minus 2x or a 7x and a minus 4x. Okay. So again, you have to take that a, that thing in front of the x squared, and multiply it by the c, the constant, get negative 18. And then you need to think of 2 numbers that multiply to negative 18 and add to 3, and that tells you how to split the middle term. You're not done. You drag down the 2x squared, you drag down the minus 9. And at first glance, what you have right here looks more complicated than what you started with. Why? Well, now it has 4 terms instead of 3 terms. Hopefully, you remember how to factor something with 4 terms. If you don't, that's okay. I'll review it now. But the reason we actually made it look more complicated is because factoring something with 4 terms is easy. When you have something with 4 terms, you use grouping. You take these 2 things, you group them together. And you take these 2 things, and you group them together. And you take out a GCF. What do 2x squared and 6x have in common? What's their GCF? 2x. What are you left with? X plus 3. What's the GCF on negative 3x minus 9? It's negative 3. What are you left with? X plus 3. You might remember when you do grouping, these 2 things are the same. Those become one of your factors. And you take the 2 GCFs, and that is your other factor. And this is how that factors. Now don't forget, we're not done. We're trying to solve this equation. So now we're going to take each factor and set it equal to 0. 2x minus 3 equals 0. We get x equals 3 halves. X plus 3 equals 0. We get x equals negative 3. And those are our 2 answers. That is not the way that I factor, personally. And it's not the way that I'd recommend factoring. I just think it's a way that a lot of you guys learned. Okay? What I would do to get from this black step to this green step is I do guess and check. And I'll show you how that works. That's what I do. So this is what I would recommend doing. You walk up to the black thing and you say, oh, the leading coefficient is not 1. It's something other than 1. So I'm going to use this guess and check technique. I know I'm going to have 2 factors. I know it's not x and x. Because if it was x and x, I just have regular x squared. Instead, it's got to be 2x and x. Like one of them's got to have a 2 and one of them's just got a 1. That's the only way you're going to get 2x squared. Second, I'm trying to figure out what number to put in the blue spot and the red spot. And I know the blue and the red, if I think about distributing, foiling it out, I know the blue and the red together have to multiply to negative 9. They have to. That's the only way I'm going to get that negative 9. And then I'm going to guess. So what could multiply to negative 9? Well, it could be like negative 9 and 1. So the green thing is my guess. Now, it's guess and check. So you got to be able to check that. Is the green numbers right? Or are the green numbers right? They're not. We know they're not because we know the answer. But how do you check that they're wrong? If you think about distributing, I know the first 2 give me 2x squared. So I know that part's right. And I know the last 2 give me negative 9. So I know that part's right. So really all you have to check is that the inner and the outer, that's supposed to give me the 3x. So you can check that real quick. Negative 9 times 2x, that's negative 18x. 1 times x, that's x, is negative 18 plus x plus 1x, 3x. No. So then I go back to the drawing table. I change the green things. and I think of other things that multiply to negative 9. And I might try negative 3 and positive 3. And I'm going to check it. Negative 6x plus 3x. No, that's negative 3x. It's supposed to be positive 3x. I'm getting closer. I'm going to go back. I'm going to say, oh, I was really close. It must be a plus 3 and a minus 3. That'd be 6x minus 3x. Oh, yeah, that's 3x. And now I have my factors. So that process I just described there is called guess and check. You just kind of guess the factors, think about distributing it out, and see if it leads back to that. You get the same answer, obviously, and that's what I would recommend doing. You don't have to do that, but that's what I'd recommend doing. Okay, a couple other things. Sorry, I got way too much writing going on here. I want to do 5 and 6 with you guys really quick. Get rid of all that. And then I'm going to let you guys try the ones on the next page. Okay, 5. Actually, no, I don't. 5 is fine. We don't need to do 5. No, we can skip 5 and 6. Actually, let's do 6 real quick. 6, h of a half. It's a plug-in. Plug in a half for x. H of a half is going to be 1 half squared plus 3 times a half. What's 1 half squared? How do you square a fraction? Top times top. Or excuse me, do you square the top, you square the bottom? 1 squared over 2 squared, that's a fourth. Plus 3 halves. I need a common denominator. That's 6 fourths. 1 fourth plus 6 fourths, that's 7 fourths. Remember, to add fractions, you need a common denominator. How did I get a common denominator? I said I want the denominators both to be 2. I multiply this by 2. I want the denominators both to be 4. I multiply this denominator by 2 to get it to be 4, and so I got to multiply the numerator by 2 as well. I'd like you to go ahead and pause, and actually I'll do one more with you guys. I'm going to do 8 with you guys. It says find x such that h of x equals 6. Okay. H of x, this one, equals 6. X squared plus 3x equals 6. It's one of the solve ones. I'm going to move the 6 over. And if you haven't noticed it yet, what we got hanging out right there is good old-fashioned quadratic formula. Okay, why is that hanging out there? For a problem like this. Okay, so you look at this problem. What multiplies to negative 6 and adds to 3? You're thinking about it. Multiplies to negative 6, adds to 3. There are no two numbers that do that. This doesn't factor. When something doesn't factor, that's when you have to use quadratic formula. Okay? So I'm going to give you a reminder about that. This is kind of the last big, probably the hardest algebra thing I'll expect you to remember. Okay? As far as this first unit here. So if you remember quadratic formula, the a is the thing in front of the x squared, the b is the thing in front of the x, and the c is the number. First thing first, just plug everything in. So opposite of b is negative 3. Yes, you do have to have quadratic formula memorized. Cool. Plus or minus the square root of b squared minus 4ac all over 2a. So I plug everything in first. I simplify what's under the square root. I do just my arithmetic. As a reminder, like I said to you guys before, we're not really using our calculator at all this first unit. Okay? And most of the units we're not going to use it. We're not going to use it a lot in the class. So I'm not using my calculator right here. I'm showing you how to simplify this by hand. So do 3 squared is 9 plus 24. 9 plus 24 is 33. All over 2. Remember that quadratic formula gives you two answers, one with a plus, one with a minus. I should still do some more simplifying here. The simplifying I should do is I should try and simplify this radical, square root of 33. But remember, when you're simplifying a radical, you're trying to split it up where one of the numbers that multiplies to 33 has to be a perfect square, like 9 or 4 or 16, and none of those go into 33. So, I'm done. Not too bad. Okay. Cool. I don't need you guys to do all of these, but why don't you pause and do, I'll show you which ones. You pause and do 13, 11, 16. Once you pause, do 11, 13, and 16. Unpause, and I'll chat through those with you. Cool. Thanks, guys. Pause. Try those problems. Actually try them. Don't just wait for me to do them. Pause. Okay, I'm going to run through them real quick. So here's our function b of x. Cool. Okay. So for 11, I got x squared plus 8x equals 20. Subtract it over. What multiplies to 20, negative 20 adds to 8. Totally factors. 10, negative 2. I get my two solutions is negative 10 and 2. Okay. Let's try 13. Similar. Subtract it over. Again, we're not using our calculator, but you got to be able to think about this. You can figure it out. What multiplies to negative 180 and adds to 8? Negative 18, positive 18, negative 10. That works. We get the solutions of 10 and negative 18. Okay. For 16, got h of x subtract the 20 over. Is that the right function? Let me just double check that. Yeah, cool. What multiplies the negative 20 adds to 3. Nothing does that. So I'm going to do quadratic formula. Opposite of b plus or minus the square root b squared minus 4ac all over 2a. It's going to give me my 2x values. I'm going to simplify what's under the square root. 9 plus 80 is 89. And I'm done. The thing under the square root, the 89, doesn't simplify, and so I'm done. Okay? Cool. All right, I'm going to pause there. The video that I need you to watch from Mrs. Fry called Function Combinations goes over pages 10 and 11. And yeah, and then we'll talk about 12 another time together. It goes over pages 10 and 11. Watch that video. I don't think that's too tricky of a topic. And then we'll chat about, then you can start your problem set, and we'll chat about page 12 when I get back. Cool. Thank you, guys. Thank you for watching this video. Please watch that function combinations video, and then you guys can start on your problem set. Cool. Don't forget, lockers due tomorrow. Thanks, guys.